Yo, hello. Oops, it's still playing in the background. Sorry about that. You may hear the music a bit with some lag, but it's fine. Um, Hello. So I'm Czech, and I decided to do a live stream. Haven't streamed for a while since the pandemic. So yay, I'm back streaming. Yeah, it's a sudden stream. There's some technical difficulty on the other platform, so I'm here, but it's absolutely fine. And if you stumble across here by accident, or you are being so lucky to be joining my stream, then please say hi on the chat. Um, yeah, so let me know that there are people watching, but otherwise I would try to download this, and then yeah, and then you may be watching it in the future. Hello, future people. So back to what we are doing now. So as the title suggests, profiling your data science work. So I stumbled across this little tool that you can use. Actually, it's not a little tool. It actually has been there for a while. Maybe some of you already heard about it. Some of you may not. But a few months ago, I realized that they have a new release with this Jupyter extension, which is very cool. That lets you profile your data science work in your Jupyter notebook. So that's what I'm going to do right now. So yeah, this tool, ta-da, is memory. So it's an open source project, and it is do memory profiling. That's what it does. So let's go back to our Jupyter notebook, because I think coding is more fun than looking at documentation. That's why I'm doing it here. So first of all, let's check what we have in this environment. I always check that because to make sure I have everything that I need. So you can see here we have a lot of things. We have memory. Like I said, we're using memory today with Jupyter Notebook. But I also have other data science things that you may want to use, like Matplotlib. Actually, I don't need Matplotlib in this demo, but I just have it. But I would use pandas in a bit, so pandas is installed. And I also have other data science thing here, scikit-learn and stuff. But for this demo, I'm mainly using pandas and see how we can profile some kind of data cleaning, data manipulation and stuff. So yeah, let's do that. So let me remove this cell. And so to use the this memory library with Jupyter Notebook is an extension. So we have to use the percentage magic to do it. So we have a percentage magic, like we all know and love. If you use Matplotlib before, you are not unfamiliar. I don't know. Like you are familiar with this percentage magic. That's how we have the Jupyter the Matplotlib inline. That's the percentage magic. That's actually some command for our Jupyter Notebook. So we load this extension called memory here, and it's loaded. So it works. Next, we want to do some profiling on some code. Before we jump into the data science work, we would first of all maybe test it out to see how we use this tool, how to interpret the frame graph, which is the reporting of this memory, and how to interpret it. So, but to use this extension to do some profiling on your code, first of all, you need another percentage magic. So percentage, and memory. Yes, I'm looking at my cheat sheet right now. So, yeah, I'm not even hiding. It's like I can't remember everything, so I have to look at my notes. So we have frame graph and memory. Okay, so now let me do some copy and pasting, because I found this very good example in their documentation. So I'm just going to copy that over here, and you see, well, I'm using Mac OS and it's not very good. Reason being that different operation system will have different way of handling memory. So I think memory, when it got developed, is mainly for Linux. So that's why Mac OS is still, there's just a warning that it may not work as perfectly as Linux systems. But if you want to know more how all this information about how memory work, how Python allocate memory, I'm giving a talk in PyCon France this weekend. So if you live in France, or if you want to go to France this weekend, so yeah, the conference itself is free, so you can join for free, but you have to get there. So yeah, so anyway, so let's look at this example here. So you see that so it's interesting because the first time we run it, there's some other so Python will have to do other like loading in module and stuff like that. So if we run it again, then we'll see what it does, like what this code does purely. So it's actually a hierarchy here. So you see that here in the top level, it is our core, right? It's A, calling A, right, with a huge number. So, and oh, by the way, if you're interested in what it does, we can have a look at what it does. It's just print out a bunch of A. So it's help. This is what it's like. So, but we are not interested in the result. We're interested in the frame graph. So let's have a look at the frame graph report. Here you see that so we call the A 10,000, no 100,000, and then A will call B. So here A will call B, and then B will call C and D. So this is what it does. And then you see that this is actually showing the hierarchy, who is calling what, and let's go layer, so top down layer. You can invert it, you can do it the bottom up, which is like this is the deepest layer, and then you go back to who is calling it, right? So you go the other way round. So which way you want to use, it depends. So some people may find this is more useful because they can just look at what's the deepest layer, but or some people prefer top down. It's also okay. It doesn't matter in this example. So this is very simple, right? You see that, okay, A is calling B, B is calling C and D, and then C and D do a bunch of things. They basically do the same thing, so they are allocated with the same amount of memory here. Okay, so this is too simple, and we can't get much out of it. So let's look at a more complicated example. Again, copy from the documentation of memory. So thank you, memory. Let's have a look. So let's run this. So this is more complicated. And you see this time, it's not as even, right? So because we are doing different things this time. And so top down, we have, again, calling A 100,000, and then A is calling B and H. And then B and H is doing different things. So you see here that, for example, this one is in H. So H is just calling one function, I. And I is doing a bunch of printing, getting a bunch of A's. So I is shouting. And then H is calling I here. So B is calling C, and then C is calling D, and D is doing this thing. So D is more complicated. D is doing a lot of things. It involves calling E, calling F, and then doing something else. So what can we get out of this? First of all, let's look at here, this two. So this is inside F. So if you look at this little black box that just show up, you can see in line 29 at the end of it in F. So so this is actually what is happening in F. So this is the return statement, and F is calling G, and G is doing this. So this is G. G is doing a bunch of okay. So you can see that F actually is the same size as G. So what does it tell me? What does it tell me is that F is actually not using extra memory, because the memory that F is holding up is actually the memory that G uses. So F doesn't add extra memory to the operation. So if you see here, the code, so F is just calling G. So F doesn't do anything, actually. So that makes sense. So that's why these two boxes are the same size. And the counterexample will be D here. D is doing, calling E and F and a bunch of stuff, right? So you can see D have a empty. So if you look at it like top down, so it's D here got a empty roof here. So if you have a roof, it means that you are actually costing memory. So D has a roof. Of course, so G doesn't have so F doesn't have a roof, right? Because F has G above it, right? So if you can see have a roof and see the sky here, like D, then you're actually costing memory. So now we know that actually, if you want to optimize things, you see who has a roof. So, and who got the biggest roof is the place that uses most memory. And then if you want to save up memory, maybe you can look at that first. So for example, G, if you want to save memory, maybe ask G to not put that many A's, I don't know, but it may not suit your use case. So, but it's an example, right? So you look at G, see if you can optimize it. You look at E, see if you can optimize it. You look at this one is I, to see if you can optimize. And also you can also look at D, because D also do something here. So this is how the frame graph works. Another side note here, I also explained in the documentation that there's one missing function. So missing is actually doing the same thing as E and I, but E and I, remember E and I have a roof. right here and then here. But missing is basically missing, right? It's not showing in the graph. So what happened? It is because missing is called within C. So C, you see that actually C is calling missing, and then it's calling D. So what happened here is that the peak of memory usage happening in D, because D do a lot of things here. So by the time, D hold up all the memory, like, so by the time it peaks, missing doesn't matter, because missing is done, right? So this statement is done, and then probably the memory got free up again, and then we call D. So missing doesn't matter in this frame graph. So you can't really optimize missing, because D is using more memory anyway, so it's like holding that much memory. So you should look at D instead of missing. So that's why missing is missing. So if you kind of because if you look into your frame graph and doesn't find some statement, that's totally fine, because it just means that is not holding up any memory. It doesn't, it's when it's hit the peak, so it doesn't really matters, and so you probably don't care, so it's not showing in the frame graph, so it's okay. So this is how you interpret a frame graph. Again, if you want to know into detail, if you want to know how Python's like using this, like for example this thing like pymalloc, what is this and what does it do and all the stuff, so I would give a more detailed explanation in my talk, so looking forward to that. Next, we would really look into how data science work, right? This is totally what, like, not something you would do day to day. This is just having funsies. So let's look at, if you are a data scientist, if you're doing data science work, how could you use memory to help you? So let's delete this again. So let's start from scratch. I'm not going to load this again because it's already loaded, so it's okay. What I'm going to do is to do what we love doing, is to import pandas. Pandas as PD. Because like all data scientists kind of can say that in their dream. It's like they do it all the time. Okay, so next I am going to load in two CSV files. So I will show you what they are. So review equals to pd.read CSV. I'm trying to give a simple example as possible. I'm not going to do like very complicated machine learning stuff, or like I just want to show you how you can use it, right? Okay, so hopefully I don't have any typos. Yes, it seems fine. Let's look at what is PD review. So I'm gonna copy and paste. I'm a slow typer. I don't want to hold up too much of your time. So let's look at PD review. So it's a review of ice cream. So BJ is, I believe is Ben and Jerry. So there's like different Ben and Jerry's ice cream, and there are all these reviews. So this data set is from Cargo. So it's you can download data from Cargo. Cargo also provide a lot of open data that you could use. So this one is just some comments on different ice cream at different times. So there are different star ratings. So cool. There's actually a lot of them. So it doesn't show how much. Okay. So if you do, for example, like length of reviews, there's a lot of them. Yeah, there's a lot of review here. Cool stuff. And next thing, we're gonna go to load another CSV. So actually I'm gonna copy and paste because I hate typing, and I told you I have a cheat sheet, so I'm gonna copy and paste, and I'm gonna load this in, and I'm gonna show you quickly what it is. Okay, so this is all the product details, so it show you what ingredient it is. So this are all not vegan ice cream because they use cream in it, but it's okay. And then there's this like how many ratings has been rated this ice cream, and what's the average rating, and description and other product details. So all is good, but but I don't quite like this, right? I don't quite like the rating because some ice cream may be more popular at a certain time. Maybe the business want to check, when the ice cream is more popular, when it's not, or maybe they change the formula sometimes, so they want to check like over time how the ice cream is performing. So what I want to do is to do some grouping. I want to group all these review into different years, so they could be analyzed according to the years. So lots of data manipulation here. So first of all, I would write a function to do that. So what I'm going to do is to do a get year statistic. Okay. So at get year statistic, what I'm going to do is, first of all, I want to do I need to aggregate by year, right? So I need to create a year for the review. So the most straightforward here, I should have shown you earlier. This stage is actually so yeah, maybe I can show it here. The date is actually pretty review dot date dot d type. So d type like this. So these are objects. So basically these are strings. So this is what I want to show you. So these are strings. So I can manipulate them as strings. So I can do this. So dot apply, and then use a lambda function x. So I took the 4 characters, which is the year. So because it's formatted as year, month, date. So for the first 4 characters will be the year of the date, right? So now I have a column year. So I can now do some group by. So what I'm gonna do is I'm gonna change a lot of things, which is probably may not be the best practice, but I'm just lazy here. So I still don't know what would be the best practice, because I haven't do any serious data science work for years, so I don't know what people do nowadays. Please comment below. Let me know how you do this stuff. Do you prefer creating more, creating another data frame, or chaining it up, or like what do you do normally? Because I do believe that like people's practices changes over time, like fraction. And after the group by, I want to so I select the stars because I want to create the average rating, right? So I would do a mean here. And of course, if you have seen my previous webinar, that I love reset index. I just don't like multi-indexing. It's very confusing. Okay, so yeah, so this is my function, and now it's got defined. It's all good. So next thing, I would like to combine this into back to this. So I create something similar like this, but create something similar, but it will be year. So it will have the year. So it won't be the average rating over from the beginning of the universe, but it will be each year. So I'm going to join the table. I'm going to join this one that I got, get year stat, to this product table. So I'm going to join by the key here. So this is the key for the product. So the year review. And then I am going to do a return. Okay, here. Right, so I'm going to use this, right? I said this is something that I want to use. I use this, and then I will set index. So my index should be the key. Okay, and this I would do a joint. So I'm chaining things up with the product. So PD product. And then what do I need? So that I don't need everything, because I don't need the rating and rating count, because I don't care about those now, because I want every year. I don't want brand and description. I hope I spell it correctly. Usually if I'm giving a talk live, I can ask people to debug for me, but right now I would have to index. So the other data frame, which is this one, I also use the key as the index, so I can join them together, and hopefully it's fine. So let's run it. No syntax error. Good. Now, okay, so this is what I'm going to do. This is my simple data science project. It's basically just group by order at which year. You can continue with that. You can put some graph and see how the popularity of different ice cream changes, but I'm not going to do that. I'm going to see in this part whether I can do some improvement before I move on. So, but first, let's see what we got for now. So year review should give me something, right? And I'm going to do a head, because it will be quite big because it's every year. So yeah, so I have For example, this ice cream have like data from 2017 to 2020 for this first ice cream of Ben & Jerry's. I'm going to have a look at how the memory usage. For this project is a small project, it may not matter that much, but if you have a huge data frame, that may actually help you. So yeah, so I'm going to do that. I'm going to copy my memory magic. So I'll put it here and have a look. So this is what it looks like. So yeah, you can see this look more complicated than our previous example because pandas, as you know, is a very complicated tool. So inside there's like multiple layers of doing multiple stuff that make sure that your data frame is doing what you want it to do. So lots of them, these are all like pandas internals. If you're interested, you can look at the source code of pandas and then contribute to pandas if you want. But let's look at something that we know what's going on. So here we see that we do dot apply, right? Here we pull out a year. So this is actually, if you compare, so I'm calling get year stat, right? So I'm calling this, and then the place that actually costs most memory. So there actually two places that we use memory is the review here and the and this apply here. So use apply use quite a lot of memory here compared to the other one. It's bigger, and is it? Yeah, you can also zoom in like this. Click on it and it will zoom in. You'll see that it's using 3.4 megabyte in total. So it's not a lightweight operation in memory. So what I can do now is to think of how I can improve this, right? I want to improve this. So what I'm going to do is to propose a change to my method here. So I'm going to create another one here. So because this is this is a string and we do some string operation. Usually string operation is not as efficient as some numeric operation. So maybe if I make it into a date, actual date, maybe this will be better. So let's do something different. So instead of just casting the year as a string, so what I can do is I can create something called dt. So this dt, actually I would want to cast the date from a string to a date time. So I'm using pd.datetime to datetime. Oh. So this is a pandas function that you can cast some data into a datetime. So I'm not going to dive into detail. You can check the documentation of how to use this, but you need a series, which is this one. And instead of this, so let me put this away for now. I tell it to infer datetime format. So pandas is very nice because it provides a lot of tools like this that you don't even need to care about how the formatting works. It would just try to do its guess. I think that it may even be optimized more if you give it a format because we know already. If you want to try it at home, you can try to do that to see if it improves even more. So let's take that away. And now we have dt. So what we're going to do is to review and then dt. So I can get the year by calling. So dt, so each element in dt should be a datetime. So I can do this lambda. So and then year will actually not be a string this time, it will be a number. So hopefully it will be better. I have to also rename this because I want to do some comparison. So I'll call it version 2. How much data it costs, right? It's like 3.4 megabytes. So let's assume this is a quite big chunk of what you're doing. So this time I'm going to use version 2. Ver2. And let's try it again. And yeah, you see all this again because like I think under the hood there's some difference the first time you run it and the second time you run it. So I'm going to run it again to make sure that I got a clean thing. So yeah, this is what it's supposed to be. So you can see our frame graph actually changed this time, and you see that we record a version 2 and then things this time changes. So interestingly, so you can see that what costs actually the most memory in this case. So you see that actually we do some datetime changes, and this actually is 9 kilobyte. But what costs the most memory here is this one, the apply. So one thing that we learn is that apply actually costs a lot of memory, and it's not a very good operation. So avoid if you can. But you can see that this is actually using quite a lot of memory as well. In another run that I've done before, this live stream, actually this saved memory. So it's kind of a bit not consistent. I don't know what happened, but you can see the difference here. So yeah, this time is smaller. So it just keeps shrinking for some reason. I think maybe some caches or something like that I don't know how to explain what's going on. But yeah, but you can see that so daytime conversion, small, lightweight. Apply, not very lightweight, so it's not actually, we don't have any improvement this time, but in my trial run actually I did have some improvement. So now you have two versions, right? So it's like, oh, it's not actually faster, you can change back. So that's why I create another one. Where is the apply here? So search index here. Yeah, so the get is, where's this one? And the lambda function is here. So this one actually now this time is very small due to string operation. So yeah, it's not very consistent. Again, this is a fairly like small data frame, so it may not matter as much. But if you're really actually doing a real, bigger data science project at your work, sometimes you may need this to make sure you optimize your code. Don't do anything, for example, element-wise operation and apply. Usually those are the suspect which like slow down your code, exploded your in-memory and stuff. So yeah, avoid those with all might. So that's it for me. Works with Python and other stuff. So also I would do this showcasing this again. So yeah, hope to see you there. And this is me for now signing off. And I hope I'm doing more now. Live stream, so we're still trying to figure out the logistic and stuff, but please be patient and pay attention to the announcement and stuff. So I will see you again sometime in the future.